Hello and welcome to. God bless you. Hello and welcome to CppChat. Very excited to have a couple of returning guests for this episode. First is Jackie K. Jackie, you're very excited. You just come back from a conference. You want to tell us where you went? We'll talk more about it later, but just tell us where you've been and what you did.
I was in Bochum, Germany, which is a historic mining town. And more importantly, for this weekend, it was the place of the emBO Embedded C++ conference. I think pronouncing the ++ is optional. Most people have just been calling it emBO. But it was a lot of fun, and I'll talk a bit about more in this episode.
We also have Robert Ramey coming back. Robert's going to talk about a library that he has in the Boost review queue. We'll talk more about that later. Robert, you want to introduce yourself?
Well, I'm Robert Ramey. I've been involved with Boost for a long time. I'm the author and maintainer of the Boost serialization library, and I've spoken at several conferences. And well, that's pretty much it. By virtue of hanging around a lot of people know my name, and nobody else has a name like that, so that's helpful. So here I am.
And you're also delightfully willing to share opinions on things, and I just love that.
If people insist, yeah.
They drag it out of you.
Yeah, generally I try not to be too proactive in that regard because some people find it off-putting. But if I'm provoked, yeah, it'll happen.
I'll hold you to that. So the big news probably this week is something that's not happening this week, but something that's happening next week, which is the Kona meeting. So the Standards Committee is meeting in Kona starting Monday through Saturday, in fact. This is an interesting meeting for them. I think that because 17 is out for review, I think they cannot make any actual changes to the standard. They can't vote anything into the standard right now. Okay. But that doesn't mean they're not going to be doing any work. They're going to take advantage of the opportunity. They're going to do a lot of work. They're going to work on doing a lot of review of a lot of issues and reviewing papers and the other things, so that once the standard is available for 20, we're always assuming it's a 3-year cycle, so the next one would be C++ 20, things are coming in. And so we've already heard people talking about kind of interesting stuff. I think there's actually someone that has been talking about kind of the roadmap for concurrency stretching out to 20. Is that what's his name? Grimmer, is that right? Anyway, so that's going to be coming up next week. So we're going to have an interesting meeting next weekend, an interesting episode next weekend. So next weekend's episode will be a little bit different in a couple of ways. One is that it won't be on Saturday, and the other is that it won't be in the morning. I'm traveling tomorrow. I'm leaving for Canada, and I will be returning next Saturday. So there won't be an episode on Saturday. Instead, we'll have it Sunday, and we're going to have it Sunday evening, which means that it makes it possible to have guests that are in a different geographic location, including Matt Bentley, who's in New Zealand, is going to be joining us. Kind of excited about that. I don't know I don't think it's general knowledge now, but there's someone in New Zealand. I can't pre-announce anything, but I think there's someone in New Zealand working on a C++ conference in New Zealand. So that is exciting to me. Yeah, very exciting, yeah. So anyway, the other thing I wanted to kind of as a business thing is to talk to people, obviously anyone in the Slack chat room right now, which we appreciate, hi guys, knows this already, but for people who might be watching this recorded viewing in YouTube, we have a live chat on Slack. The team is CPP Lang, and the channel is CppChat. And I'm have been a little bit confused. I think I've gotten this straightened out now. But for some reason, I wasn't invited. I just joined without being invited. And this seems weird to me. But Jackie explains that what it is there's an auto-inviter. So if you go to a certain URL, then you can auto-invite yourself. It sends you an invite. Is that how it works, Jackie? You want to explain that?
Yeah. Yeah, by default, Slack is designed for teams at offices and companies, so it's invite only, but you can installed this web extension that just authorizes people to sign themselves up for public teams, which is what we are. We're a team. C++ is a team.
And I wanted to move our chat to it from IRC because I kind of wanted to take advantage of all the excitement that's going on in the CPP Lang team, because there's a lot of discussion going on there. In fact, if you read it all, you'll get no other work done. That's pretty clear. But it is nice. Yeah, Fawn's saying, go team. It is pretty nice to have some place you can really quick go and say, hey, what is the deal with whatever? I mean, it's nice to have CPP reference that you can look stuff up, but sometimes it's hard to know what word you're searching on or something like that. So it's nice to be able to just ask real users in real time without sending an email and waiting for a response, but in real time say, what's the deal with X? And I kind of wanted to leverage that and improve on that. So that's why we moved, and I want to see more and more people in the C++ community at least being accessible on CPP Lang, even if you're not watching it every day, which, as I say, means you don't get any work done. I'm learning this the hard way.
Yeah, I'm amazed by the number of experts who are just readily accessible and posting, like Matt Goldbolt, Jason Turner, Anthony Williams. It's just incredible. It's really cool.
Yeah, Louis is on there, Joel's on there, Michael Case is on there. So if you have a metaprogramming question, I mean, it's just like,
yeah,
there's a metaprogramming Slack. You just type in your question, and you're going to get great answers. It's better than Stack Overflow. What can I say? That's just amazing. So that's kind of why I wanted to move over to it. And I would encourage anyone who's just watching the video, even if you know, oh, I'm never available to watch it live, so why should I want to check out the chat room? And my answer is, you want to check out the chat room for all the other things. We're just a small part of what's going on Slack. We're the best part, but a small part. Is that right? All right. The other thing is, Jason has reminded me that I teased everybody about an announcement about C++ Now, that you had to watch this show if you want to know what the announcement was, because I wasn't going to announce it formally. So here's the deal. It's a major enhancement to C++ Now. I'm very excited about it. I've been wanting this for a long time. In fact, I haven't even been thinking about it a lot, because I just think, well, we could never make that happen. And this year, it just came together. We were able to make it happen. And frankly, we may not be able to do it next year. It just, this year, some things happened, and we're going to be able to do it this year. And I'm really excited about it. But I'm kind of hesitant to announce it. And the reason is, even though it makes the conference much better, it's actually an argument to not go to the conference. So if you're not teased enough, here's the announcement. The team that does the recording and editing of videos at CppCon, Bash Films, is going to be recording all of the films, the sessions at C++ Now. So we're going to have professionally recorded and edited videos. They will be of higher quality. They will, and they will also be up almost certainly in better time than what we've normally been able to do. And I want to thank Marshall and the volunteers that have done the recording in the past. It's great, and all the videos are, there may be a few situations where the audio is not great or something like that, but there's wonderful value. If you go to YouTube and look on the BoostCon channel, there's great sessions there. And I don't want to disparage that or belittle all the effort that went into that. But looking at CppCon videos, we know that better is possible and more timely is possible, because relying on volunteer laborers that have, in Marshall's case, I think he's basically doing 2 full-time jobs between the Standard and Qualcomm and LLVM and libc++. He's got his hands full. And then also editing and posting C++ Now videos was just really demanding, and that's why it took a while to get them up sometimes. And we know that Bash Films is capable of incredible turnaround times for us. So I'm very excited about all this. The thing is, no one's going to actually notice this when we're at the conference. It's only going to be later when we appreciate it. And as I say, in theory, it's an argument to not attend the conference. But anybody who's been to CppCon and watched a CppCon video realizes there's a world difference. You really do want to be there. It's nice to have the videos, partly for people who were there. I point this out. People say, well, wait a minute. You're giving away the videos free, so people who don't go to the conference, get all this value. And it's like, no, the real purpose of the videos is because we run multiple tracks. And the people who most want to see the videos are usually people who painfully decided not to go to one session because they went to a different session. And so having the videos is great, and having them of high quality is just really wonderful. So we will be formally announcing this video upgrade, and it's great because we've been able to do this partly because Bash was able to come up with a way to make it less expensive for us, and because we've had great sponsorship this year. So what I would say is, if you want high quality videos at C++ Now, try to get your company to sponsor, because that's what's going to make it possible.
My two thoughts on this are, first of all, a huge part of the value of, most of the value of C++ Now is the attendees, the quality generally of the minds at the conference, the random conversations that come up, I think, not just in the presentations. Presentations are also of huge quality. And you could also say this is an argument to go, because if you sit in the audience and ask an important question or bring something up, that will be immortalized in a video more people are going to watch because they're going to be of higher quality and probably, publicized more this year. So, I don't know.
Well, that's a two-edged sword. I've had the personal experience of getting spanked in public from asking a question. And it's perhaps character building, but it's not pleasant. And now, of course, it's on YouTube for posterity. So.
One of the things I would say, and both of you have spoken at C++ Now, so you know what I'm talking about, but there are not many sessions that I've been to at C++ Now where someone didn't point out an error that someone either said, or more likely a syntax error on the slide or something like that.
That's the least of it.
Yeah, this is an audience, and I tell people this: if you present, and I remember having this discussion with someone who I was trying to get to submit, and I said, look, you will have an error on one of your slides, and it will be pointed out to you. But it's going to be in a nice way. It really is a collaborative environment. And I think part of that comes from the fact that C++ is just hard, and we're all in this together. If it was easy and you screwed up, then we would make fun of you and say, what an idiot. But when it's this hard and you screw up, everybody is like, oh, by the way, you probably want to fix this. And everybody knows internally, yeah, the reason I caught that is because, I did it myself. So being immortalized as to somehow being a flawed human is not going to be the end of the world. Okay, let's see what's going on in C++ Now. I should tease this. We have really gone overboard. We have invited probably a record number of keynotes for C++ Now. And I know that some people don't like the keynotes because they actually prefer the breakouts. And I know one of the biggest advocates of this position is Michael Case, who told me, I don't like the keynotes. I'd rather have the breakouts. And I told him what we're planning to do for keynotes, and even he was excited. He said, oh, that sounds pretty good. So I hope that's a great tease. I can't announce anything. We only have, we don't have commitments from people. And so we don't know what's going to happen. And this is interesting. But I'm really looking forward to what we're trying to do this year with keynotes. It sounds like it's going to be a lot of fun, and likely to be, there's going to be a lot of discussions about this. Anything else? Oh, the student volunteer announcements, which I have now promised now for 2 weeks. But Bryce has promised that this is coming out next week. And he's going to be in Kona working on the standards committee. I don't see how he could possibly release this next week. So, I don't send emails to me, send emails to Bryce. Or he's on Slack, send chats to Slack to Bryce and say,
is Bryce on Slack now?
Well, yeah, he's at Wash. That's his name, Wash. So just say at Wash. And I don't know how much time he spends hanging out, but he's got an account, and if you @wash him, I think he'll see that. He'll be notified of it. Okay, so enough about C++ now. I think the next thing we want to talk about is emBO, emBO++. So tell us about the conference, and then tell us about your talk.
Sure. So it's this is the first time this conference has been put on, and it was very small, around 50 people. But I think that was a nice setting for what we were talking about, because essentially given the kind of state of the industry right now, we were talking about some pretty radical ideas, which is using high-level abstractions on small embedded bare metal devices, and that's not widely accepted in the industry, apparently. So I'm actually kind of more of a hobbyist in this field. I've used a lot of this software and then decided, you know what, I want to try looking at bringing metaprogramming, high-level stuff to these kinds of platforms, which is how I got involved, working a little bit with Odin Holmes and his project, which is called Kvasir, which is really hard to pronounce. But essentially, I've been spending some of my free time working with them, trying to bring that library up to production quality, or at least better, a state that's we can share with people better. So that's why I went to this conference. It was obviously just one track because it was so small. The first talk, which I really enjoyed, was by Bartek. I'm not even going to try to pronounce his last name. It's Polish. But he had this really fun presentation that was just going through different code examples with C style and C++ style for different tasks. And he benchmarked them on a desktop x86 computer, a Raspberry Pi running Linux, and then a 32-bit bare metal ARM, like Cortex M something device. Like same code, all these different devices, several different examples. He benchmarked the code size and the number of cycles, and the C++ style examples outperformed the C every time. They were either the statistics he gathered were either as good as or better on C++. Obviously those were just chosen. Yes, Robert.
And what about memory size? Were those statistics also gathered?
So yeah, I don't know if he measured static and dynamic memory usage. I think it was just binary size and number of clock cycles. But that would be a great an email asking him to see if he can change this.
I mean, that always comes up. Because I touch on this area on a regular basis, and that two things come up. One is mainly that comes up is the idea that C++ generates an executable which is much larger. I don't think it's true, but on the other hand, I don't have any examples I can pull out to demonstrate that it's not. So I think that you might ask him about that, because I think that people would ask that.
So I think this is something that Dan Sachs has been talking about, is the fact that C++ was doing really well in the embedded community for a while. People in the embedded community were considering C++ and making that transition, which for some people was, heresy. Oh my, it's use something in C. But Dan's saying, we've kind of been losing out on this because we've been so excited about all these modern features, and we were talking about that, and that kind of alienates people in the embedded community because they weren't necessarily thinking that lambdas were the solution to all problems or something like that. And that's why it was great to have not only him but also Jason Turner's keynote at CppCon, both of which were really strongly making the argument that C++ has a place in small memory footprints and low-powered platforms because these things are so powerful. So I'm glad what Odin's doing, and I'm glad that you were able to do that, Jackie. It sounds like this is an argument that needs to be made, and we need to, C++ is not the language for everyone in every application. I'm the first person to admit that. The software that I use to run the conferences is written in Python, right? That's because it never has to be performant. It's never going to run for a lot of data. There's just no reason. Write it quick, low maintenance. That's what I'm looking for. But embedded is not. Embedded is a sweet spot for C++. We want to write really, really low resource software, and that's the sweet spot for embedded. And so we just need to make this argument. We need to make it clear what C++ can do and show people those benefits. That argument needs to be made so that we don't, like I say, C++ isn't going to win every situation, but we should win the ones where on merits we should win. And that argument needs to be made. We need to overcome stereotypes that C++, and Robert's making the point, some people think it creates bloated code. Some people are going to think, oh my gosh, you use virtual functions. How inefficient.
Well, but there's also, it's being ignored the fact that there are real issues here. Some small systems don't work well with RTTI. Some certain kinds of systems, exceptions is not really an option. If you use library code, it might have exceptions built in. And there's, the dynamic allocation can be an issue, which doesn't, some environments don't really have that in a comfortable way, and yet the libraries presumes the existence of that. So I think that if you get down to some real applications, then you'll find that it's not as obvious to substitute C++ as it would first seem when you start out.
Yeah, I think that's a really important point, and it also it means that most of the standard library is off limits for those platforms which use, because exceptions kind of permeate the code base, and the standard containers are all dynamic by default allocator interface, but it's not great. There's strings are all dynamic memory, and that's
If you're going to say it's going to be C++, but we're not going to use the standard library, it's not really C++ anymore.
Well, you can use your own. You can use your own allocators. Use an allocator that doesn't.
Could be.
Yeah, there's
so
allocator interface. It's all right, but yeah.
Jason made a he said a random anecdote in the chat room. He says, I was just talking to a developer who did a proof of concept move from C to C++ for his company, and the C++ was 75% smaller binary, 25% smaller RAM,
Nice.
and two times faster. So, for what it's worth,
I can believe that.
I guess the important thing is for us to know. I mean, that's not going to prove it to anyone, but for us to say this is worth exploiting. There are things about C++. The example I always give, of course, is comparing sort to qsort, because sort can inline your comparator, and if you're writing code with qsort and you have the option to move to C++, that's going to.
Well, I'm betting a lot of it is when I take a C application which has been running embedded systems for a while, and then I turn out and say, oh, I'm going to do a proof of concept against C++. One thing I'm going to be doing is throwing out all the ad hoc code that all those programmers put in there thinking that they could do it better, and I'm going to be replacing it with library code that's just been vetted and hammered on for years, and just regardless of the language, just improvement of the quality of the code. The better, the less code you write, the better your product is. And so I'm guessing a significant part is just being able to leverage all the much better stuff that's available as part of the standard libraries. It's hard to separate out, of course.
Yeah, my suspicion is that the source size will probably reduce a lot too.
Oh, by probably factor 10.
Yeah, and that's not insignificant for people who have to maintain that code.
So that's another kind of cultural difference, I think, between C and C++ programmers is C programmers like things to be absolutely explicit, and that often kind of leads to code duplication, where they say, we're writing out exactly how it is for this use case and for this platform and for what we're doing here, and rather than abstracting out patterns like we do in C++, or like we love to do, I think, in C++.
Right. They assume the compiler can't do any thinking, so they have to tell it exactly,
Yeah.
you want to do this and this, rather than, you know, our attitude is, oh, the compiler should be smart enough to figure out that it doesn't need to do that, right? And very often,
Yeah, we trust our compilers. Mm-hmm.
Well, I think that they're onto something there, because one reason C++ is so complicated is you have to outguess the compiler all the time. It's where it's going to look up something. You know, if you write an operator and it takes a certain type, well, you've got argument-dependent lookup, and so you could actually add another module totally distinct in your program, and then discover that your program doesn't function the same anymore. They don't have that problem because it's a lot more explicit. Of course, they still have the implicit numeric transformations, which I'm sure create a lot of problem. But a big problem with C++ is everybody wants it to be smarter than the programmer that's writing it, which means when you write something, you can't really know what it's really going to do in many cases.
And I understand that's the source of anxiety. I mean, someone writes...
Well, yeah, if you're writing an ABS system or whatever, sure.
Well, yeah, so somebody writes A plus B, and the C programmer just becomes, you know, apoplectic at the idea, wait a minute, that plus is a function call, and that function could do disk access. The function could do absolutely anything in the middle of my plus. And the answer is yes, it could, but that's a really bad design. I mean, you know, people, in other words, theoretically, all this could happen, and theoretically, argument-dependent lookup could destroy your program. But in practice, that's no worse than if I said, oh, I call this function that's called log, and what it really does is format your drive or, you know, whatever. I mean, that's, of course, that's possible, but anybody who wrote a function called log that formatted your drive would probably not be part of the team any longer. Well, the same thing is true of, you know, I write A plus B, and it goes out and does a disk access. That's probably not going to be team building.
Makes an HTTP request to, you know, look up.
I mean, you know, I think those are examples a little extreme, but I still think it's a real problem, and I think C++ covers a multitude of programming sins in a way that makes you feel that your program is more correct than you can actually demonstrate that it is. And now the things that we're making are so gigantic, nobody's really making the whole thing. I'm importing code from all over the place, which I might have a document with it, but oftentimes might not. And I'm pressured to do it because of time constraints. I do it, it works great. But now I lost control of it. I don't really know what it does anymore. I don't even know if I've got a list and I got a vector, and now I'm being told in some quarters, well, I shouldn't use the list because, in fact, it's slower because of cache locality and stuff like that. So I'm kind of handing over the certainty that my program will work into someplace else. Not even then, we're not even touching on C++ compiler optimizations, which is like a whole new can of worms. So anyway,
but if I could make an analogy, I mean, consider that, you know, it used to be that there were people who understood exactly how their car worked to the point where they could replace every little part on their car. And now nobody can do that because the most important part of your car is a chip. And there's no way that you're going to actually go in and, you know, tweak that chip and lube it up or do what else, right? I mean, you know, when things get complicated, that doesn't mean they're not better. Now, it does mean that they're complicated. But, you know, in response to you, Robert, it's the reason you're doing it is because it extends your reach. If you had to write all that code yourself, you'd be way less productive. And the trade-off is, and this is an inevitable trade-off, even if it was a C language, a C library, you wouldn't really know what that C library is doing. You're still giving up a certain amount of control.
Right, and I think we could be, and I'm aware of that, but I think that we could do a lot more to ameliorate the downside of it.
Well, I think the most important thing is just to be aware of that and think about that when we design libraries and when the committee gets together and talks. So enough of this particular rat hole. Jackie, we didn't talk about your particular talk. So anything else you want to say about the conference? Was it a good environment? Was it?
Oh,
no, please tell me it was not as good as
friendly.
CppCon. That's the most important thing. Reassure me that.
It was a lot more kind of experimental, I think, because there was sort of a feeling of we're at the beginning of a movement, which is we're going to get all these C programmers onto C++ using not just C++, but modern C++ and metaprogramming and all this stuff. So we had an SG14 meeting at the end of the day. SG14 is a study group for the C++ Standard Committee on low latency, real-time systems, video gaming, financial, high-frequency trading, and now embedded systems as well. And Michael Wong was there, so he's the head of that group, and he was kind of advising the group on how to move forward, like how to approach the standards committee. Should we have we discussed a lot, should we have a kind of standard library for embedded? Should we try to push want standardized or in the standard library into the mainline, or have like a TS or different namespace or something that's for embedded? And that was a rich discussion. But the conclusion of that was we really need to have people making libraries, sharing them and testing them, using a lot of the ideas that we had discussed about using modern C++ for better safety and pushing more logic to compile time, that kind of thing. So we need to have more libraries and test them, kind of like a boost for embedded, or submit things to boost. And then that can be a path to standardization of those library level things. So then with regards to my talk, I decided, one thing I think about a lot is if we're going to write better code, we should have better static analysis. Static analysis is really cool because you can empower your compiler to catch bugs before you even run your code. That's kind of cool because, especially on embedded systems, debugging is hard. You can't print stuff to screen necessarily because you don't have a screen. So I wrote a static analysis tool using Clang Tidy. So it's a Clang Tidy check. And what I did was I took the memory map for an embedded device. So the memory map is a map of addresses that represent registers. And when you write to registers, stuff happens. Usually you're interacting with the peripherals on the embedded device. And so I took memory map and looked for raw to those memory addresses using Clang Tidy. And the idea is you could use that to refactor an existing code base, like an embedded SDK, to use a higher level way of writing to those. So that's one thing that Odin's library Kvasir does, is it has this abstraction for register writes. So the talk needed a little bit of context, I think, to really know the value of it, because you need to be familiar with Odin's library, which has this high-level wrapper over low-level register writes, which usually have like a volatile pointer dereference and look really crazy. But it was a lot of fun to put together. It was the first time I had really hacked on Clang, and I learned how to write an AST matcher. In general, there's like tons and tons of really good talks on how to write a Clang Tidy check and how to use the Clang AST online. And I would refer someone interested in doing those to that, not my talk, but if you're interested in combining, what I did was, I think, kind of unusual, which is combining like platform, not just platform specific, but hardware specific stuff with Clang Tidy and the whole Clang framework. So it's fun.
So
the slides, yeah.
If I was trying to write for a particular target, I could make target specific extensions to Clang Tidy to work for my particular application. And that is kind of an interesting approach. Given that our tools, particularly that particular tool, is open source, why not put your requirements right in the tool? Interesting.
Yeah. Yeah, and I think a lot of chip vendors or device vendors have a closed source stack of like debugger tools and analysis tools. And I'm a total open source hippie, and I like things to be transparent. And I actually think it's more efficient if a lot of software, if it's open source, if you find a bug and you make a fix, it's just saying something's wrong and waiting on the developers to, look at it. So yeah, and also, I guess to that point, one technical detail is to make this check, there are these XML files that describe the memory layout of these devices, and all of those are open, and so there's huge potential to make debugger tools and stuff that are cross-platform across vendors and also open source. But not a lot of people leverage those. It's mostly these vendors making their own thing, and yeah.
So was the talk well received?
Yeah, I think so. It was short. I actually Odin asked me to speak, and I was like, yeah, I'll prepare something, but not for a whole hour. I'm kind of busy, and but so it was like a 30-minute talk, but there were a lot of questions.
We have the opposite problem at CppCast now. We're trying to trim people's talks all the time.
Yeah. Well, I saw that something on Twitter where I think Bryce said, like, not a single submission has an aggregate score of reject. What are we supposed to do?
Yeah,
I don't know if he was supposed to say that.
No, it's really tough. The submissions look really good this year, and we're going to have to say no. In fact, the deadline, the responses are going to go out tomorrow, and 90% of them are deadlocked. We know. The problem is, as I said, we're trying to be aggressive about keynotes. Every time we have a new keynote, that's three breakout sessions because we have 3 tracks, right? So it's really going to be tough to cut down. I think we've got it pretty easily. We got it down to about 42 sessions, and then I told Bryce, no, we have to cut 3 more sessions, and he's saying, I can't cut 3 more sessions. So now we're looking at, well, are there some sessions that could be shorter? I mean, what can we do, right? Anyway, so people in the chat room are talking about Misra, and we should maybe have a completely different episode about Misra, because I have some thoughts that I don't want to get started on Misra, because we need to talk about Safe Numerics. Robert has his library coming up for review in Boost. It's submitted to Boost. When's it coming up, Robert?
I think the review starts March 2nd, and I think it goes for 10 days. I think that's it. I don't know the detail. There's a couple things about the review that I'd like to mention, in that I've always been promoting the idea or ways that we can get more reviewers in a Boost of a Boost library. A couple of libraries have been accepted with just 2 reviews, and I think that's a bad idea. So I think the review process helps the library development immensely. I would like to see more people get involved in it. If you can't fit the time frame, or you're interested in the subject but would like to post a review, but you don't want to get involved in the back and forth, or you're not going to be around that time or whatever, you can also make an advanced review either on the mailing list, or you can also, in the Boost Library Incubator, you can post your review there and it'll be considered by the review manager. So I would hope to see a larger number of reviews than we normally have. I'd like to see 10, but we'll see how that works out.
So in order to do a review, you have to be paid up on your Boost membership, and if your reviews are paid up?
No, actually, you have to contact me directly and ask permission to submit a review.
No, I just want to make it clear to people, even if you've never been to Boost before, we want reviews from literally everyone. If you're a C++ programmer, then we think you should be using Boost libraries, and so we want your opinion on Boost libraries. So that was just my point, was that anyone can go and go to Boost and look for...
Currently, you actually have to be a member of the Boost mailing list in order to submit a review, but now that requirement is non-existent, because you can go to the Boost Library Incubator, and if you just sign in there, and you can post your review right there, and it'll be included as if it were put directly on the Boost mailing list. So that's a facility that hasn't been widely used, to my disappointment, but even though it's still there. And I think that this is this is a subject which is might be of a little wider interest than a lot of some other Boost libraries engaged in more arcane areas like template metaprogramming and stuff like that.
And I also want to point out that I'm certain Robert would love it if you would do a very thorough code review of every part of the library, but it's also valuable if all you do is read the documentation, because that's how people are going to learn about the library. And if you read the documentation and can point out this could be clear, or this seems ambiguous, or this seems contradictory, or whatever, that's valuable itself. Of course, it's even better if you can go further, but if that's all you can do, we want that review as well. Right, Robert?
Well, you know, I don't think you've been strong enough about that point. I've made a big deal. I've complained numerous times about the poor quality of Boost documentation, which is a cut above documentation in other places, and it's still atrocious in many cases. I did a whole session on the Boost Units library, and the whole thrust of the session was the library is really important, but the documentation makes it almost unusable. 5 people showed up to that session, so I guess that I'm out of the mainstream there. But I believe that I have strong feelings about making a Boost type library. The preparation of the documentation has to be codependent or developed in parallel with the library itself. And so I spent the Safe Numerics thing is for me, it's a big topic, and it's not generally well received. So I've invested a lot of effort to make examples and use cases and address all the concerns that people raise by having simple examples which illustrate why they're wrong and why I'm right. And so I also gave a talk, which I can tell on the YouTube thumbs up and thumbs down has been very well received, about the Safe Numerics library. It's probably due to the fact that it was very short, and it was only 15 minutes or 20 minutes, and it describes how useful it is to people who don't want to know anything about C++. And so I started out this thing as kind of a lark, and it kind of got me by the throat, and now here I am.
Send me that link so we can include that in the show notes, the description on YouTube, so that's easily accessible for anyone watching the video, or put it in.
I'll put it in the chat room right now.
Yeah, put the URL in the chat room, and I'll harvest it from there. But this is, we have to admit, this is pretty narrow, right? I mean, this library is only useful for people whose programs have numbers in them, right?
Well, you know, when you the one important point here, and this is well, actually, you're one of the big, how should I say, people who brought this up in a very obvious way, and I know that Jackie and Bryce had was meant to be humorous interchange on unsigned versus signed integers. It's pretty sad that it's humorous, because it really, what it means is that you cannot take any arithmetic formula which includes integers, which is totally transparently obvious what it does, code it in C exactly as written, and you cannot have the faith that it will produce a correct arithmetic result. Now, if we've got programs with millions of expressions like that, and we have programs that are doing things like running ABS systems, and when this occurs, we get no indication that it occurred and produced the wrong result. It gets propagated to the rest of the program. The reason this is not a big topic is because most of the time it doesn't happen, and what it does, we never know about it. We just produce a wrong result, and some guy gets logged out, and then he logs back in, and that's the end of it. But the stuff that we're building today cannot survive this attitude. That's my point.
Yeah. Okay.
And another interesting thing is this is not a C++ thing. It's not a C thing. Almost all computer languages that based on binary arithmetic have this problem. I mean, you have it in as far as I know, just about every single language, and they've all decided not to address it because it's a pain in the neck.
Yeah. I imagine that doing it completely seems like it would take a huge performance hit, and certainly in C++ we don't want that. So what we need is a really, really well thought out library that gives us level of safety and comfort, but not expensive at runtime. Anybody have an idea about a library like that?
Well, yeah, this is it. The thing going on here is that everybody raises that objection. My view is, if you're not really concerned about the right result, you might as well have the main return, and you're gonna have just as much confidence in the result, but you'll save a lot of time. So, but as a practical matter, the way this library, and I confronted this, and I realized that this thing would never ever fly. And there are other libraries which do address this, but it would never ever fly if it was perceived to be a performance hit. And the final version right now basically does a range arithmetic on all the integer values at compile time, so that it can predict ahead of time which operations might overflow. And if you want to spend a little time specifying a little more information about your integers, you can build a program and know for a fact that it will never suffer from overflow, sign change problems, implicit conversions. You will know that it will never produce an incorrect result, and you will have zero performance hit. So this, in my view, is the first time that anybody's been willing to address this real problem in a way that is actually usable.
So then if I have a value that is runtime determined, I have to annotate it with a valid range, and
for example, let's suppose I have a value that fits in an integer. It fits in an 8-bit integer. Now, if I had two of those and multiply them together, I know because of C++ type promotion rules that those will be promoted to ints, but there'll be ints that have values less than 256. And and the product of those will fit into an integer. So in that particular case, there's absolutely no reason to be concerned about getting an invalid result. So so in particular cases, there's no checking code, no runtime checking code is necessary. And there's things, and I use constant expression a lot. So it may be that in many programs, they won't suffer any noticeable hit at all. On the other hand, as a practical matter, what I would envision happening is somebody would replace all their ints with a safe integer, and then they would discover some slow spots. And what they might do is say, oh, this particular integer, I've assigned it to an int, which is 32 bits on my machine. I'm going to replace that with a 8-bit integer. Or there's a facility, I might be able to use, rather than a safe type, a safe range, and specify what the range of that value is actually I expect it to be. And so the first level would be just to do a global replace. The second level would then be perhaps annotate particular functions or particular variables to specify their range, at least where the slow spots of the program is. So I see this as actually a real practical method of guaranteeing that your program won't produce an incorrect result without overburdening you with writing and rewriting the whole thing in such a way to try to avoid that. So we'll have to see. But
so also send me the URL to the library so that people can know how to review it. Right?
Okay.
Because I'm hoping that people respond to this by reviewing it. It would be amazing if we could get 10 reviews, as you said, and I think we can do it. It's not like this is some really esoteric corner of the world. I made the joke about, it only applies to programs that have numbers in them. We all deal with numbers, and it's embarrassing to think about that if you were to write a function whose only job is to add two integers together. That's actually really hard to do if you want to do that in a safe way, because you don't know, you have to detect overflow in advance, then you have to decide what you're going to do in that case, and it's a really complicated mess.
Well, that's the funny thing. Even if you try and apply the guidelines at the CERT guidelines, they're impossible to apply in any practical notion of programming. You basically would have to do the whole thing in assembler. So, no, it's a fact, because if I say I plus j, no problem. But what if I go I plus j times k? Now, wait a minute here. We got an intermediate calculation which is buried in there. So how the heck would I reprogram around that to avoid the whole issue? I would end up with a subroutine that's like 15 lines long. So anyway, that's, well, anyway, I don't know what to say about that.
Okay. Well, go ahead and post the URLs, and we'll hope for the best as far as reviews.
I think the easiest thing, I put the URL of the Boost Library Incubator. It's there, and then if you fiddle with it and have a comment about it, or if you want to make a review of it, you can do that also right there.
Okay.
It also looks like John McFarlane in the Slack channel posted a link to your GitHub repository.
Okay,
so I think
you can do that too.
So I forgot to ask you, Jackie, did your talk get recorded?
Yes, actually, all the talks were recorded. I have no idea when they'll be online. So,
right. So when it becomes available online, we will edit the description of this episode. So remember to do that. Send me that URL when you do that. And sometime in the future, if you're watching this episode, sometime in the future, that will magically appear. So we don't have a lot of time left, but I did want to talk about CppCast. Those of you who've been watching the episodes a lot know that I have this incredible envy, because they do things so professionally and they're so well organized. Robert does such a good job, and Jason too, who I want to point out is watching us on the chat, or at least he was earlier. And they interviewed this this week. The interview was with Bjorn. Let's see, I had his name here somewhere. Bjorn Faller on Trumpole. At least the interesting thing was in the episode, everybody recognized that nobody knew how to pronounce it. So that's a great thing about a library. That's a library that nobody exactly knows how to pronounce. But I guess we mostly write things anyway, so it doesn't matter. Right?
A native French speaker on Slack did say Bjorn's pronunciation of it was very good.
Oh, okay.
So,
right. Okay. So, but this is a mocking library. Anyway, it's a great episode. He was talking about how he kind of rolled his own because his company used Google Mock, but that was preventing him from using some advanced C++ stuff or some modern C++ stuff. So he kind of rolled his own. The other thing I forgot to do, important business here, I forgot to read the disclaimer for this episode, which is, under Washington law, an equine sponsor or professional shall not be liable for an injury to or the death of a participant in equine activities resulting from the inherent risk of equine activities. So keep that in mind as you use this episode. Appreciate that. So the other thing that caught my mind this week was a post on Reddit. The Reddit said, did knowing FP, that is functional programming, we wouldn't want to actually have to write out functional programming. It was better to do jargon here. Did knowing FP actually helped you write better C++? And this caused an interesting discussion here. I guess I tend to think so. I had a friend a coworker actually. He quit the company I was working at, and he went and worked for a company that wrote everything in Scala. For those of you who don't know, Scala is a functional programming language that's based on the JVM. And what I told him was that whether he ever came back to C++ or not, I didn't know. But I said, if you do come back to C++, you'll probably be a better C++ programmer for having internalized how to think like a functional programming programmer. Was I wrong to say that?
I might buy that. It's, I see, I don't know, it's hard for me to say because, as I say, since I've been involved in template metaprogramming a long time, it's kind of natural to me. But I also see the limitations of it, which the promoters of it don't seem to see. So I do believe that just adding certain ideas into your code, like immutable types, constantness, functions without side effects, constant functions, just trying to incorporate more of those stuff, that kind of bag of tricks. I think that helps your programming a lot without really even understanding the whole concept of the functional programming and the monoids and monads and functors and wow, yeah. So I think if you just kind of steal a couple tricks from that, it'll help your code significantly.
I think I need, on every episode, I need to put up an M word warning. If the M word is used in this episode, I think viewers have a right to know, to be warned about that. Strong
content warning
language used in this episode, right?
We're going to use the F word. Yeah, definitely functional programming. It's almost like there's pure functional programming, and then there's functional styles, like kind of stealing tricks, like Robert was saying. And it definitely, if you have pure functional, a purely functional program, you can't really do much that's interesting. But what's a useful pattern some people find is like separating out the state and separating out kind of the functions, composing transformations on that state, and that can be really elegant. And it's actually, I think that style is very popular in the web world. I'm not a web developer. Before this episode, we were talking about the subject and talking about, well, show me a good use case for this, for really functional styles. And some web apps and mobile apps too, like people using Clojure on mobile. Clojure is a very functional paradigm. It is starting to become very popular. So,
right. I think there's a lot we learn. One is that anyone who wants to use template metaprogramming, it has to be functional. You can't do assignments and you never modify a type, right? You just create a new type. So it's a very functional style. If you've never done any functional programming, it takes a little bit to get used to it. But if you came from a functional background, you'd say, well, this is just straightforward. And the other thing I think is at runtime, that anything that's functional doesn't have side effects. It is very multi-threading friendly. And I think that's going to be more and more important to us in the future. So I really think that what I see is that it's another thing to keep in mind. In other words, you want to be const correct. You want to think about these things. And I think you want to be side effect correct, which is to say, we don't want side effects except when we do. Because as Jackie said, a purely functional language essentially can't do anything interesting because it can't have any I/O, right? It can't modify any state. And the world in which we live, progress happens when state gets modified. But
well, I think you hit it on the head here, and this is the kind of the thing that's missing is the promoters of functional programming and all this stuff have this view, but unfortunately, it kind of excludes a real part of the real world. And in those of us in the C++ world, we're interested in it, but we don't have a good way of reconciling it with some of the stuff we want to do. I think there's just somebody who has to see this and find and really discover what the right pattern is. I've been trying to do this, and part of my efforts were in the last CppCon when I talked about C++ and abstract algebra. But and I think that has promise. But right now, we're kind of flailing around, and we are getting some benefits from the tricks, but that's, I think, is as far as it's going right now.
One last thing to bring this all full circle. I really want to see is people exploring these high-level ideas about how we can use theory to prove things about our programs and better safety in embedded systems. Well,
you and I are in exactly the same page here.
Well, that's a great time to wrap it all up when we're all on the same page. So
exactly.
I want to remind everyone again that we will have an episode again next weekend, but it will be 33 hours later. It will be Sunday evening instead of Saturday morning, at least California time. So whatever time it normally is, add 33 hours to that, and I think if my math is correct. Otherwise, I want to thank very much Jackie for being with us, and Robert. Thank you guys both.
Thank you.
And I want to say safe coding.
Yeah. Okay.
Especially
we're a safe numeric, huh?
Yeah. All right. See everybody next week. Bye.
Bye.